Hey everyone, and welcome. Today, we're going to open up what is basically the first aid kit for the internet. If you've ever felt totally lost when your connection goes down, you're about to get your hands on the network admin's Swiss Army knife. These are 3 incredibly powerful tools that can diagnose pretty much any connectivity problem you can think of. So, let's dive in. Seriously, think about it for a second. Was it yesterday? Maybe even this morning? We have all been there, right? Just staring at a loading screen, feeling completely powerless. But what if you weren't powerless? What if you could actually ask the network direct questions and find out exactly what's going on? Well, you absolutely can, and that's what we're about to learn how to do. So our journey into network diagnostics starts with the most basic, most fundamental question you can ask any device on a network. It's literally the first word in any troubleshooting conversation, and that word is ping. At its core, ping does one simple thing. And it does it brilliantly. It just checks for a sign of life. Before you go diving into really complex routing issues or DNS problems, you've got to ask the most basic question. Is the server I'm trying to reach even awake? Ping gives you that answer, loud and clear. You know, there's this really beautiful metaphor for this. Using ping is like shouting, Maya Makalesa, which just means, can you hear me, into a giant canyon, and then just listening for the echo. It's that simple and honestly, that profound. You send a signal out and you wait to see if you get one back. So how does this echo actually work in the digital world? Well, your computer sends out this tiny little packet of data called an ICMP echo request. The easiest way to think about it is you're throwing a ball at a wall. The server on the other end catches it, and if it's working right, it immediately sends back an ICMP echo reply. It throws the ball right back to you. The whole thing is really just a simple game of digital catch. And the info you get back is pure gold. When you see reply from, that means, yes, the server is alive. The time value, that's the super important round trip time. It tells you how long it took for your ball to get there and come back. And trust me, lower is always better. Then you'll see TTL, or time to live. Think of it like a self-destruct timer on the packet, so it doesn't just loop around the internet forever. But the most important thing to look at, packets lost. If that number is anything other than 0, it means some of your throws are getting dropped, and boom, you've just found a problem. Okay, so ping is great. It can tell you that there's a problem, like, say, a really slow connection, but it doesn't tell you where the slowdown is happening. For that, we need our second tool. Let's move on to Traceroute and see how it builds on what ping told us. So if ping is like shouting into a canyon, Traceroute is like the GPS for your data. It doesn't just tell you that you arrived at your destination, it gives you the full turn-by-turn directions. It shows you every single router, we call them hops, that your data passes through on its way. But here's the really mind-bending part. How can your computer possibly map out a path it's never seen? It doesn't start with a map of the internet. It actually builds the map as it goes along, using this brilliant little trick. Okay, so here's the magic. First, Traceroute sends out a packet that's intentionally designed to fail. It sets that time to live value we talked about, the TTL, to just 1. So the very first router it hits reduces that TTL to 0, the packet expires, and that router sends a message back to you saying, hey, your packet died right here at my address. And just like that, you've identified hop number 1. Then, you guessed it, it does the exact same thing again, but this time it sends a packet with a TTL of 2. Now this packet makes it past the first router, but it dies at the second one. The second router sends back its own little expired message, and now you've identified hop number 2. And this process just keeps on repeating. TTL of 3, TTL of 4, all the way up. With each step, it gets a response from the next router in the chain, until the packet finally makes it all the way to its destination. It's kind of genius, right? By forcing each stop on the journey to identify itself, Traceroute builds a complete map of the route from scratch. Oh, and just a quick pro tip here. While the tool is basically the same everywhere, the command itself is slightly different depending on your computer. If you're on Windows, you'll type Tracert, but on a Mac or a Linux machine, it's the full word, Traceroute. A tiny little detail, but a really important one to remember. All right, so we can check if a server's online and we can map the exact path to it, but what if the problem is that your computer doesn't even know where to send the ball in the first place? This is where our third and final tool, Nslookup, comes into the picture. The best way to think of Nslookup is as the internet's address book or maybe its phone book. See, we humans are great at remembering names, like Google.com, but computers, they only understand numbers, IP addresses. Nslookup is the tool that lets us peek into that phone book, called the DNS, and look up the right number for a name. So when is this the exact tool you need to pull out of the bag? Well, there's a very specific and pretty common scenario where Nslookup is the only thing that can solve the mystery. Here it is. Let's say you type google.com into your browser and nothing happens. It just fails. But then you happen to know its IP address. You type that in, like 142.250.187.174, and poof, it works perfectly. That means you don't have a connectivity problem. You have a name problem. Your computer's address book is broken, and Nslookup is the tool that proves it. And there you have it. 3 tools, 3 simple questions, 1 really powerful diagnostic process. Ping, Traceroute, and Nslookup aren't just 3 separate commands. They're designed to work together as your complete network investigation tool. So let's just recap how it all fits together. First, you start with ping to ask the simple question, are you there? That just confirms basic life. If it's slow or it's failing, you move on to Traceroute to ask, okay, how do I get there? That'll map the path and show you where the delays are. And if you can't connect by name at all, you pull out Nslookup to ask, wait, what's your address? To check if it's a DNS issue. Now look, hearing about this stuff is one thing, but actually doing it is where it really clicks. So here's a little challenge for you. Open up your terminal or command prompt, ping a website you use every day, and check out the time. Then, ping a site on a totally different continent. You'll see a big difference. Then, traceroute that distant site. You will be amazed at how many hops it takes to get there in a fraction of a second. Go on, give it a shot. Now that you're armed with the ability to ask the network the right questions, you're not just a passive user anymore. You're an investigator. The next time something goes wrong, you'll know exactly where to start looking. So, the only question left is, what network mysteries are you ready to solve?